All right. Good morning. My name is Arun Vamori. I'm with the DHS Science and Technology Directorate's Biometric and Identity Technology Center. First of all, we'd like to thank you for joining us today to learn more about some of the results of our 2020 Biometric Technology Rally in 2020. We definitely appreciate you taking the time to learn more about our efforts. It was one of the more unusual years of running a rally, and I really want to celebrate our team who helped to execute the rally this year. On the phone or on the telecom with us in this video, I'm joined by my colleagues Jacob Hasselgren, John Howard, Yevgeny Sorotin, and Jerry Tipton. I'll go ahead and get us started and hand off to each one of my colleagues to brief different parts of the briefing deck. We'd like to ask that you hold questions till the end. You can put them into, I think, the Q&A or the chat box, and we'll take them at the end of the webinar. And again, we look forward to your questions. We look forward to explaining some of the things that we saw with the rally, explaining some of the results if there's any confusion, and making sure that there's greater visibility and awareness and transparency on various issues. So let's go ahead and get started to the next slide. So today, during this webinar, we're going to give you an overview of the 2020 Biometric Technology Rally. We'll provide a quick intro on the Biometric and Identity Technology Center, how we've used technology rallies previously and up to now, some of the unique things about the 2020 Biometric Technology Rally and how we adapted it for the COVID-19 pandemic. And then talk a little bit more about about the system providers and the people who participated in the test. My colleagues will provide additional information about how the acquisition systems were tested and how they performed, how the matching systems were tested and performed, and we'll go through any conclusions and answer any questions you may have. One of the things before we get started here, actually, I think it's on my next slide. I'll wait for a moment. So, who are we? What are we doing? The Biometric and Identity Technology Center are a group of science and engineering technical subject matter experts with strong expertise in biometric and identity technology. We basically provide core research, development, test, and evaluation capabilities for DHS and DHS stakeholders, domestically and internationally. Our goal is to help facilitate, honestly, understanding and accelerate understanding on the use of these technologies, how they work, what their capabilities are, what their limitations are, and how certain risks and issues could be mitigated. We focus on trying to share knowledge across different missions and stakeholders to help facilitate learning, to address the issues that often happen with the learning curve, and help organizations learn how to use these technologies effectively, securely, fairly, much better, so that it doesn't take as much time or difficulty to start implementing these capabilities in an effective way. So to do this, we support cross-cutting best practices, cross-cutting solutions to drive operational efficiencies. We provide objective test and evaluation capabilities across the department for anybody who has interests and needs. The goal is to make sure that people have a fair and clear understanding of how the technologies work, where the challenges are, and then honestly what can be done to help address them and make them better. We also work actively with industry. You all know this today. We do a strong industry outreach to try to help orient industry about our use cases, our challenges, our problems, to enable you to develop better solutions, but also where our goal is to provide better feedback to you so that you can help make better technologies that will address the various operational, legal, privacy, and civil rights and civil liberties concerns. And largely, we're here as a catalyst. Our goal is to encourage innovation across the Homeland Security enterprise. Next slide. So the Biometric Technology Rallies, what are they? So these are relatively unique opportunities. One of the things that we do here is, unlike a lot of other biometric technology of tests that happen in various parts of the world, this is a test of scenario testing. It's not a technology test, it's a use case, it's an evaluation of how a specific type of operation or use case could be supported by biometric technologies. We're focusing primarily on use cases that address needs both in government but in the private sector. Our goal is to help industry evaluate, to become aware of these use cases, to build technologies that will effectively address them, and receive feedback to make the technologies more effective over time. We want to identify and mitigate risks associated with the use of these new technologies, and provide objective feedback, not only to the potential buyers and users of the technologies, but the people who are building these technologies to make them and looking to sell or make them available to governments or various organizations that have similar needs. A lot of our rallies, or actually all of our rallies for the last few years, have focused on this idea of high throughput inspection or screening, where we are looking at screening large numbers of volunteers or large numbers of people in a matter of minutes. And this is really kind of thinking along the lines of like border controls, physical access controls, aviation security, any sort of like potentially surface transportation, any number of different areas. And we do our evaluations not only on things like biometric matching performance, things like true match rates or false match rates or false not match rates. We're looking at a variety of things. We're looking at efficiency. How long does it take people to perform the tasks or the functions? How much staffing might be required? Effectiveness. What kind of error rates are we seeing with the use of the technology? User satisfaction. Do we expect pushback? Do we expect that people who are using the technologies will have difficulty using them, resulting in either low adoption or honestly unhappy users? Neither one is a good thing. Privacy. We have an interest in promoting technologies that work in certain ways so that we can help address and minimize privacy risks to the people using the technologies. And equitability. Does it work well for all people? In our rallies, we test with a naive population of volunteers. In some cases, we'll bring back people who have some familiarity with different biometric technologies. We've evaluated dozens of combinations of commercial technologies over the years, finger, face, and iris. In this particular rally, a lot of focus, or a lot of the providers were focused on face recognition for this high throughput use case. However, we also had a few technologies focused on around iris recognition. And for more information, please visit the MDTF website, mdtf.org. Next slide. So 2020 was an unusual year. We had planned for a biometric technology rally that was focused again on high throughput use cases, where we had limited limited staffing to help screen hundreds or thousands of travelers or individuals very, very quickly. Due to the COVID-19 national emergency, we realized we needed to make a change. And we had originally planned to be able to process small groups of users going through these various technologies and solutions quickly. But however, due to the emergencies, we decided to defer screening small groups and instead focus on the new issues of how do we handle people who need to verify their identity, but they're wearing face masks, which could pose a challenge to traditional operations where we rely upon things like photo IDs. And to get into the details, I'll go ahead and turn things over to my colleague. So now we'll talk about the Biometric Technology Rally timeline. So please go ahead. Thank you.
Thanks, Arun. This is Jake Housegren. Yeah, so before we get into some of the results that we observed, I just wanted to give a couple of logistics and an overview of the test itself. So as Arun said, going over the timeline, we had our initial call for participation in March of 2020. Any interested parties had a little bit over a month to submit an application. And following the application, we obviously did a little bit of review from a number of different organizations. And from there, we were able to send conditional acceptances to those that we had selected would perform well during the rally. And following conditional acceptance, we gave those selected technology providers 4 months to build and develop their systems to be installed at the facility. So at the end of September, we had those providers install their systems, and then immediately following, at the beginning of October, we performed the rally data collection. I will note that between the time of conditional acceptance and the installation at the facility, we did host a cloud API, which mirrored the API that would be used during physically at the installation at the facility, and this would allow for technology providers and participants to test their systems while they are building it up. Next slide. Okay, so we did receive a number of applications. Total, we received 24 applications from different companies that were actually headquartered in 6 different countries, so it was a pretty broad interest. Like I said, these applications were reviewed by a panel of experts from a number of different organizations, and those include DHS, DoD, NIST, and other industry parties. So we had a good broad spectrum of different reviewers to make sure that we had the systems that would perform well. And in the end, we chose 6 acquisition systems and 13 matching systems, sorry, to be participants during this 2020 rally. Next slide. Okay, so as everyone said, we had to switch focus here a bit because of the COVID-19 pandemic, and obviously, as we are all aware, there was a large spike in the use of face masks due to state and local government instituted mandates, but also people just protecting themselves. So that became a focus of one of the focuses of the 2020 rally. And at the time, many biometric systems required masks to be removed. So in these different systems, you had to remove the mask, which increased the risk of infection for anyone who was taking off those masks. So obviously, this became of interest to us. And when we finally decided to switch focus, we had already selected our participants. So we made sure to ask those selected to participate whether their system would be able to, whether they can provide a system that would work with masks. And this was an overwhelming positive response. So every system that we had chosen to participate, including the 6 acquisition systems and the 13 matching systems, all stated that they could provide a Rally system that worked with masks. So this was a good to hear, and it was definitely a positive response for us because this was a change that was made in response to emergency. So this is good news for us. Next slide. Okay, so a couple more logistics about the acquisition system test, and then I'll go over some of the results for the acquisition systems, and then we'll transfer over to Yevgeny for the matching system results. Next slide. Okay, so for the acquisition systems, we had set a number of criteria for them to meet, and this is what we used not only during our review but throughout the test. So we had a couple of minimum requirements for acquisition systems. First, they had to operate in an unmanned mode. So René mentioned this was a high-throughput scenario, and to accomplish this, we decided to use an unmanned mode like our previous rallies, so no operator or instructor. They had to operate within a given footprint, so we chose 6 foot by 8 foot, and that was defined by us and was carried over from previous rallies. So we wanted to make sure that these systems were capable of fitting in certain areas. Each system had to collect at least face biometric imagery for identification operations, and each system had to provide only one biometric probe image per test volunteer per modality. And the system had to process and submit biometric data within time constraints defined by DHS S&T. Essentially, the system had to send those probe images before the test volunteer had left the station. Optionally, the acquisition systems could provide other modalities, iris and fingerprint modalities specifically. We didn't have any fingerprint systems in this rally, but we did have an iris system. As we had stated, we wanted to make sure these systems were able to handle masks. So another requirement was that these systems could acquire images from people wearing face masks. Next slide. Okay, just to give you an idea of what the test station looked like and how we handled it. So similar to our previous rallies, we had our group of volunteers that will line up at the station. They would provide their ground truth identity via a QR code on a wristband that they were wearing. So that was scanned before they entered the station. And when they entered the station, they crossed a beam break, and then they interacted with the system depending on how the system instructed them to interact with it. And then the volunteer would leave the station crossing another beam break, and then finally would rate their satisfaction with that system using a satisfaction kiosk. At the end of the collection, we had a good number of volunteers. So we had 582 volunteers that ended up using each system. We made sure that those volunteers use those systems in a counterbalancing order so we can distribute the learning effect across the systems. Like I said, we had systems that submitted face images, iris images, or a combination of both those modalities. And each volunteer used each system twice. The first time that they used the system, they took off their masks, so they had a without mask test condition. And then the second time they used the system, they kept their masks on. And finally, I think this is important to note. There was a lot of people that came into our facility, and there was a lot of staff that was required to complete this test. But we were able to keep social distancing maintained at all times during the test. And we did this by using a number of different tools, such as indicators on the floor, and also different signs in things. But we also required everyone to wear masks throughout the test unless they were using a system, and we made sure that social distancing was maintained so that the risk was minimized. Next slide, please. Okay, so I will go through an overview of some of the results for acquisition system metrics. I will say that the acquisition system metrics pertain to the without mask condition, and I'll let Gene or Yevgeny get into some of the mask conditions with the matching system results. Also, each one of these metrics have a threshold and a goal value. So the threshold value is a value that we thought each system should be able to accomplish, and the goal value is the value that would exceed our expectations. Next slide. Okay, so the first metric I want to go over is efficiency. So efficiency we quantified as the average transaction time for a test volunteer to interact with a system at each rally station. And if you can remember the little graphic that I had a couple of slides ago, we considered it, we calculated transaction time by calculating the time between the first beam break and the second beam break. Like I said, this was only for the no mask condition. And for this metric, we had 4 systems, Bezic, Stone, Bly, and West, that met the threshold, with Stone, Bly, and West actually exceeding the goal. And the threshold value was under 8 seconds, and the goal value was equal to or under 4 seconds. Next slide, please. Oh, sorry. The most efficient system was West at a 3.5 second average. Now, next slide. Sorry about that. Okay, so the next metric that I'd like to go over is satisfaction. So for this test, we measured satisfaction by looking at the positive attitudes that these volunteers had towards these acquisition systems. And we considered a positive attitude anything that was happy or very happy. These satisfaction ratings were recorded on a satisfaction kiosk that had 4 buttons. It ranged from very happy to very unhappy. So yeah, like I said, the positive responses were anything that were rated happy or very happy. We had 5 systems that met the threshold: Bly, Pine, Bezic, Dans, and West. And that threshold value was greater than 90%. And then 3 systems, Bezic, Dans, and West, exceeded the goal value of satisfaction score of 95%. We did observe that the most satisfying system was West, which was a 99% happy or very happy rating. And I will mention, using these names, we did assign an alias to each one of these systems. So if you have any questions, feel free to email DHS. Next slide. Okay, so the next metric I'd like to go over is the failure to acquire rate. So this was quantified as a proportion of test volunteers who no images of sufficient quality were obtained to template. So this could happen in two ways. A, there was either no image received, or B, we did receive an image and it just was not, we were not able to template it. So we assessed this for each modality separately. We had three systems, VLI, West, and DANS, that met the threshold value being a failure to acquire rate under 5%. We didn't have any system that actually met the goal of under 1% failure to acquire rate. The lowest failure to acquire rate that we did observe was from the system VLI, and that was a 1.7% failure to acquire rate. Next slide, please. Okay, so the final metric that I'd like to go over for acquisition systems is the MDTF true identification rate. And this is quantified as the proportion of test volunteers that were correctly identified using our internal matching system at the MDTF. Again, like failure to acquire rate, this was assessed for each modality. And for the true identification rate, we had three systems that met the threshold value being greater than 95%, and those were West, DANS, and VLI. And again, we did not have any acquisition systems that met the goal value of 99% MDTF true identification rate. The highest true identification rate that we did notice was the FACE system VLI, and that had a true identification rate of 97.8%. Next slide, please. Okay, so just to give you a quick result summary of the acquisition systems, like I said, these are all without masks. For efficiency, we did have 4 acquisition systems FACE that met the threshold value of 8 seconds or less, and 3 of those met the goal value, exceeded the goal value of equal to 4 seconds or less. For satisfaction rating, we had 5 acquisition systems that met the threshold value of 90% or greater. 3 of those exceeded the goal of 95% or greater. For effectiveness, we didn't have any systems that met the failure to acquire goal of under 1% or a true identification rate goal of greater than 99%. We did have 3 FACE acquisition systems that met the failure to acquire threshold of under 5%, and we did have 3 FACE acquisition systems that met the true identification rate threshold of greater than 95%. And we did observe that acquisition of images remains a challenge for the iris modality. Okay, so next slide, please. And at this point, I will hand off to Yevgeny to give a overview of the matching system analysis and the results. Thank you.
Thanks, Jake. Next slide, please. So I'd like to go over the results for the matching systems. As we previously stated, we had a total of 10 FACE matching systems and 3 iris matching systems participating in the rally in 2020. What this slide captures are the technical requirements for each matching system. I'll just cover the main points, which are that the systems were all delivered within a self-contained Docker image, implementing a simplified biometric rally matching API. So critically, each matching system provider also attested to the fact that their system could match images of people wearing masks. And this was really a critical component of the assessment, since we looked at the way that these matching systems performed, both with people wearing masks and people without masks separately. So next slide, please. So each matching system was evaluated in combination with each acquisition system. This is something that we do for the rally. We sort of disaggregate the results by acquisition system, and this resulted in a total of 60 FACE system combinations and 3 iris system combinations. The evaluation of performance was by performing matching against a small historic gallery of individuals. This gallery contained 500 identities in it. And each system was evaluated based on how well they identified individuals in two conditions during this test. So as I mentioned before, we looked at how well the systems perform without masks, which means that volunteers removed their masks by either dipping or taking them off fully prior to using the system, or with volunteers keeping their masks on in the with masks condition, where volunteers kept their masks on while using the system and didn't remove them ahead of time. And all acquisition systems and matching systems were given distinct aliases in the with masks and without masks condition. So definitely we wanted to maintain the privacy of the companies in reporting the with masks results, because this was a new type of assessment for this year, and we didn't want to link the performance. This is something that came up later. So next slide, please. This slide shows a video, and I don't know if we could play the video. It captures the variety of different face masks that were observed during the 2020 rally. So it shows masks worn, personal masks worn by individuals, and these are the masks that they wore in the images acquired by the various acquisition systems. Of course, these are face images. We had black masks, blue masks, white masks, masks with patterned, complicated designs on them. We had a lot of bandanas and various other types of masks. So there was a lot of variety in what the acquisition matching systems needed to handle in the with masks condition. So next slide, please. So as I mentioned previously, we evaluated matching and acquisition system combinations, and we evaluated them on their ability to correctly identify each test volunteer. We looked at two metrics. For the full system tier metric, we looked at the performance of the overall combination of the matching and acquisition system, inclusive of all sources of error. So this metric is true identification rate, and it's expressed as the percentage of people that use the system who were correctly identified by the system. So the fraction here is the correct identifications divided by the total number of people in the test. In the matching tier, we took a look still at system combinations, but we discounted any failures to submit images based on failure to acquire the image by the acquisition system. So this is what we call a matching focus tier, and it's expressed as the percentage of acquired images that were correctly identified. So in this case, the fraction is correct identifications divided by the number of images acquired. And this helps us sort of zone in specifically on the matching system performance, those still disaggregated by the source of the acquisition images. And in both cases, we set goals and thresholds ahead of time. We were looking for a 99% or higher true identification rate, and threshold value was 95%. So if the system achieves better than 95%, then we consider it a viable high throughput system. Whereas if the performance is below 95%, maybe it's not a viable high throughput system. Next slide, please. So here's a matrix of the results. So there's this is for face system performance. Each one of these matrices, there's one on the left without masks, and there's one on the right with masks. It shows the performance of that system combination. Let's look at without masks first. So without masks, there were 4 matching systems: Mommy, James, Reese, and Pearl. that achieved above a 99% true identification rate with at least one acquisition system. In this case, they all achieved it with acquisition system West. And the top true identification rate value was 99.7% for system combination MOMI West. And that's highlighted by this black box that you see in the chart. And these charts are available at mdtf.org as well. So about a third of the system combinations achieved a true identification rate value above threshold, 95%, which is pretty good. And this sort of matches the performance that we've seen previously in other rallies. Performance with masks, on the other hand, was a bit lower, not unexpectedly so. We are obscuring roughly half the face. But the top system combination, Alan Frey, did manage to obtain a true identification rate of 95.9%, which is inclusive of all sources of error. And we think that's pretty good because it meets the Rally threshold for a high throughput acquisition system and matching system. So overall, in addition, 10% of the system combinations, even with masks, had true identification values above 90%, which are sort of within striking distance of the threshold. Next slide, please. So next we took a look at the matching focused true identification rate. Remember, this one discounts any failures to submit images by the acquisition system. And in this case, things look significantly better. So a third of the system combinations were able to meet the goal for this metric without masks. The best system combination was actually, in this case, Stone Pearl. It was the best. The values are similar to some of the others because of rounding, but it achieved a performance of 99.8% matching focused true identification rate without masks. With masks, things look better as well. Many of the systems were able to now meet the 95% threshold. In this case, nearly a quarter, in fact, were able to do so in this more challenging condition. And the best system combination with masks was Glen Allen, which, again, discounting failures to submit images, that system combination was able to match 98.7% of images that were acquired. So next slide, please. So we also had an iris acquisition and matching system in this assessment. We had 3 matching systems and 1 iris acquisition system, so there's going to be 3 values disaggregated. However, it was challenging it's always more challenging, it appears to be more challenging to acquire iris images. And you could see in both without masks and the with masks condition, there was no system combination that met the threshold or goal, certainly not goal, requirements for iris matching. Next slide, please. However, discounting failures to submit images, the matching systems worked very well, both without masks and with masks. So although without masks, none of the system combinations met the goal, with masks, actually one of the system combinations did meet the goal, and that's a little bit maybe paradoxical, but what happened was, the images, when the iris images were acquired, they tended to match very well when the subjects were wearing face masks. However, overall, more images for more subjects were not acquired in this condition. So we think that based on these results that there's some promise to iris biometrics, so long as we can work on the failure to submit rate a little bit. Next slide, please. So this summarizes the matching system results. For the full system true identification rate, overall 23 face system combinations met the Rally threshold. 4 face system combinations met the Rally goal. and one face system combination was able to meet the threshold with masks. No iris system combinations met these requirements in either test condition. For matching focused true identification rate, again, discounting failures to submit images, there are now 47 face system combination out of the 60 that met the threshold, and 22 met the goal, so very strong performance. With masks, 14 face system combinations met the threshold, none met the goal. 3 iris system combinations met the threshold without masks, none met the goal. And 3 iris system combinations met the threshold with masks, and 1 did meet the goal. So next slide, please. Okay, so the conclusions from the assessment are as follows. Overall, the tested acquisition systems had very fast transaction times and high user satisfaction, as Jake told us earlier. As in prior rallies, the largest source of error in the biometric performance here is image acquisition, not matching performance, primarily having to do with missing images for some volunteers that use the system. The face masks did challenge current systems in these high throughput operations, which was manifested by increases in failure to acquire, as well as some reductions in matching accuracy. Face recognition systems can perform very well in the presence of masks, as evidenced by good performance observed for some system combinations. For instance, the top full system tier value with mask was 95.9% for Alan Frey. And the top matching focused true identification rate with masks was 98.7% by combination Alan Glenn. We think that these are values that could be attained by other system combinations in future testing. Iris matching systems, although they tended to underperform, they have potential. Acquisition system errors were greater for iris, but iris matching focused true identification rates were comparable to face matching focused true identification rates. We believe that if image acquisition is improved, then iris system performance may be comparable to performance of face systems in the future. Next slide, please. And at this point, I'm going to hand things off to my colleague, John Howard, who's going to describe a new matching system evaluation that we have planned.
So thanks, Arun, Jake, Evgeny, for sort of walking through the 2020 results. Hopefully that makes sense to everybody on the line, but it can be a lot of numbers. So I think we're going to stick around, fill in questions for as long as we can. But before we sort of get to that Q&A session, I did want to take just a slide or two to let everyone know about a new initiative from the Biometric and Identity Tech Center. We're calling this the Ongoing Matching System Evaluation. And sort of the genesis of the effort is this, as most of the acquisition vendors can attest, really since the very first rally, we sort of pride ourselves on the ability to get results from our tests out quickly. The acquisition vendors, for example, leave on the last day of the rally with sort of this preliminary report card that explains how well we think they did. The matching system evaluations have always sort of been a little bit more of a challenge, and that's largely driven by two things. One, it's just a lot more numbers to deal with. There's typically more matching systems and acquisition systems. That was the case this year and last year. And two, the technical support for the matching systems isn't on site. So when the acquisition vendors come, their technical teams come with them, they keep their systems up and running. Largely, the matching system technical support is still remote. So it's usually a sort of effort between our engineering team and the matching system vendors to sort of keep these systems working, troubleshooting things. Things like Docker and our APIs help, but there can still be challenges. But we think after 2 years of doing these matching system evaluations that both sort of our internal processes and the matching system vendors themselves, folks on the line, sort of matured in this process to the point where we're ready to start doing more automated short-term matching system evaluation. In order to achieve that, a couple of things need to change, and I'm going to just run through them very quickly. First, the picture you see here on the right should be familiar to all the matching system vendors. This is the info endpoint of the API you implement as part of your Rally submission. As of last week, this was upgraded to version 1.1, and we added 2 fields to this info object. I can't point because I'm over a phone, but they're the last 2 fields you see sort of in the image. They're test and threshold fields. The first field here, I'll just explain what they are, is test. The idea here is that this would be one of a few preset values that tells us what kind of test you'd like to run on your matching system. I actually have a full slide on this right after this, so I'll talk to that a little bit more in a second. The second addition to this info object is this threshold field, and that's where you would sort of place your 1 in 1,000, 1 in 10,000, 1 in 100,000, etc. match thresholds. You guys will probably recall that these are previously sort of emailed to the MDTF around the time we start executing the Rally matching system. This mechanism would sort of replace that manual email step, which is, obviously going to facilitate us running this whole process in a little bit more of an automated fashion. The second high-level thing that would change to sort of enable this ongoing evaluation is the way you send us the matching system. So matching system vendors typically have done this with whatever internal process they like. When people email them to us, some people put them on an S3 or an FTP link. Now what we're going to move to is we're simply going to host an upload form at mdtf.org, where with a username and password, you can just upload a tar file, and that'll sort of be securely pulled down into one of our enclave environments. We'll test that you conform to the API, a couple of other things in terms of just size and memory requirements, and then we'll run the evaluation that you specify in that test field. We think this capability will be coming online over the summer of 2021. But the idea here is that once you do go through that upload process, our systems are going to use the information kind of contained in this info object, namely the technical contact email, you see the threshold and the test, and we'll automatically execute an evaluation of your matching system and email you the result. Next slide. So it should be slide 30. This should be, I think, the last slide before we get into Q&A. I mentioned I would talk more about what the test field is. I think when this capability rolls out, this may be limited to a few values that we'll slowly add to over time. But basically, the idea is we have a couple of predefined tests. You tell us which ones you'd like to run against your matching system. One that's obviously low-hanging fruit for us is what's populated in the field now, this capital MDTF_2020_Rally test type. That, for example, would simply rerun the exact analysis that Evgeny presented earlier for a single matching system, and the result would look like something in the picture shown below there. You would see your matching system, both masked and unmasked performance across the different probe images gathered by the various Rally acquisition systems, and then we would just automatically sort of attach this in an email and send it back to whoever is the technical contact in that field. This would hopefully all happen, sort of depending on the test and a few other factors, fairly quickly. Maybe we're talking order minutes to hours from the time you submit this, so this could be a potentially a quick turn, achievable objective. The goal here is sort of to allow you, if you want, to run ongoing evaluations of your algorithm on some of the MDTF data. So Gene had that really nice movie slide earlier that sort of looked at all this mass data we collected. Exactly what MDTF data we would potentially design these test rounds is something we're currently soliciting feedback on. We do have this opportunity at MDTF to collect these really rich data sets, because every time we run a test, it's new people. There's some portions of our population we've been working for years, others are new. We get to sort of refine the questions and the measurements we take every time a new set of people comes in. So we get things like self-identified race and gender. We've done some work taking skin tone measurements with sort of this dermatology equipment. One of the sort of the next additional thing, in addition to just the regular Rally 2020 analysis that we think about rolling out, is to sort of deaggregate the Rally 2020 results by those self-reported demographic categories I mentioned, race and gender. Note that we currently don't do that as part of the Rally public results on the website. So everything that Evgeny and Jake talked to today, everything that's on the website, it doesn't really mention performance by a demographic category. But we think, especially in terms of this latest mask challenge, that's part of the 2020 Rally, there may be some interesting findings there that can be sort of interest to matching system vendors, namely that there's sort of this unequal impact of mass to performance when things are broken down by race categories. Is any of this really of interest to the Rally matching system community? I hope so, but I really don't know. And so to sort of help us better understand what kinds of testing, which for your product development goals, we're currently open to feedback in this area. I'll note this is something that's only open to groups that have this sort of ongoing creative with DHS. So it's not like a NIST FRVT style evaluation where really anyone in the world can submit it to. This is supposed to be something that provides value on more of an ongoing basis just to the people that participated in the rally. We hope that you'll sort of reach out and work with us to understand what those evaluations might be in the future. Next slide. And I think this is my last slide. There's the email address to provide that feedback of people screening. And with that, Arun, I think I'll turn it back over to you.
Thank you very much. We appreciate your time. And again, reach out if you have any issues, questions, or feedback. Thank you very much.
Thank you, everyone.